Hello. So what I'm doing is taking a look at this question right here and trying to help you out with the answer. It's impossible for me to tell you exactly what's going um, on this question because I don't know what the values are. I think this one is a skateboarder one where he's skating up the hill. And the thing about this is he's skating up the hill and he has speed at the beginning, so he has kinetic energy. And that kinetic energy is going to go up. And how high he goes, this height here, will um, be determined by how fast he's going. This kinetic energy will take him up to a certain height. And so this kinetic energy um, is our total energy at the beginning. So we have our little um, graphs once again where we have the bottom of the hill. This time, the bottom of the hill, it's the same exact idea. He's going up. So whatever the kinetic energy he has here, this is 100%. And the potential energy, this is kinetic. The potential energy at the bottom is 0. And so the total energy, which is the ME, is also going to be 100%. And so law of conservation of energy says this energy is going to transform into potential energy at the top. So then if we have one at the top, we have potential energy, we have kinetic energy, and we have mechanical energy. This is assuming there's no friction. So at the top, there will be no kinetic energy. It'll all be potential. And so it's 100%, which will be the same as whatever we established here was 100% at the top. So how high he goes will be this equation here, mgh, and we solve for that h. So the first step, number 1, we solve for that. And then step number 2, we say, okay, that's going to give us our potential energy, GPE. And then step number 3, we solve for height. And so that's that question. There's a second question you asked me. And the second question was this one here. And I'm going to take a little screenshot of this part right here and drag that over and answer this one now. And so this one is, I'll just scoot this down. So this one has you answer the same thing. You answer the same way a bunch of times. Like it's the same equation each time, meaning that what you have at the top here is potential energy, and it's potential energy, and it's potential energy. Right? So it's the same in each case because we're rising to the same amount each time. That's how high we're going. That's the H. But the way we go up the hill this way, this is our D, and our D is changing. Our H is staying the same, and our D is changing. This one, you're going straight up and down. So your D and your H are actually the same thing. And the way you get up the hill is you do work. And so the equation is like this. The work that we do to get up the hill is going to give us our potential energy at the top of the hill. And work is described as whatever the force is times the distance. That is going to be equal to, at the top of the hill, the mgh. So our mass is usually, in this case, it's 0.5. Our gravity on Earth is 9.8. The h is 0.3, and that's always true. H is 0.3. And so this side of the equation will always be 1.47 joules. This side of the equation is going to be the one that changes based upon this idea, this force distance, this force distance, this force distance, and this force distance is the force distance to get us to the top of the hill. Now the distance is getting, let's see, ramp A, B, C, D, E. The distance is getting shorter and shorter and shorter. So as the distance gets shorter and shorter and shorter, the force should get greater and greater and greater. So for instance, this first one is going to be unknown average force times 0.6. That's the 0.6 right there for ramp A. This is ramp A. And so if we put that in there, we get F equals 0.6, and we divide each side by 0.6. And you'll get F equals whatever this is in newtons. And that will be the first answer. The actual weight of the cart, well, weight is Fg, and Fg is just equal to mg. And so it's just this part of it. This is actually weight. Height is how high you bring it up, which is the 0.3 right there. And so that's basically how you answer each one of these questions, where for each one of these questions, the D is going to change, right? And so if the D changes, then you're going to get a different ratio of force and distance. These numbers should get greater as you go down. This is ramp E. Ramp E is this last one here. This one's interesting because this last one, you're basically lifting the weight of the cart. So the weight of the cart, M times G, is 0.5 times 9.8 newtons per kilogram. And so this will give you half of that is 4.9 newtons, and that's the weight. So this is 4.9 newtons. Well, guess what? This is also 4.9 newtons. Why? Because you have to lift the entire weight of the cart. Instead of that weight being distributed over time and distance, and making it easier, then when you lift something up, you have to lift the whole weight. So this bottom one will be the same as that. You'll see, if you put in the equation, it will turn out to be 4.9 because 0.3 will be here. And if you put this over 0.3, you get the same answer before. So anyways, try to see if these actually help you with what you're doing, okay?